Hey everybody, how's it going? Welcome back to the next episode in the Project Euler archive series. My name is Jake. I make programming videos on YouTube. If you like them, like and subscribe. All right. So today the problem is lattice paths, number 15. Starting in the top left corner of a 2x2 grid and only being able to move to the right and down, there are exactly 6 routes to the bottom right corner. How many such routes are there through a 20x20 grid? All right, so the way we're going to do this is we're going to start with a 2D array representing the grid, and each value in the grid will represent the number of routes to that coordinate point in the grid. So for example, at this point, coordinate point 0, 0, we ask the question, how many routes are there to get to the coordinate point 0, 0? There's only one, because that's where you start. There's no other option. How about this point? How many possible ways can you get to the coordinate point 0, 1? Well, of course, there's only one way. You just have to go right? Because you can only go right and down. And the same logic applies for anything in the top row, because to get to, if we expanded this to a 20x20 grid, imagine you wanted to figure out how many possible routes are there to get to the point 0, 14. Well, there's only one possible way to do that, and that would be to go right 14 times. Okay, and the same logic applies for the first column, because to get to any point in the first column, your only option is to just go down. All right. So that's how our grid starts, and then to fill out the rest of the grid, you'll notice that if I want to figure out how many possible routes are there to this point, point 1, 1 in this situation, what I would have to do is I would have to find the sum of the coordinate point to the right, the sum of the coordinate points to the left and up. So if there's one possible way to get to this point and one possible way to get to this point, that follows that there must be 2 possible ways to get to this point. It's just the sum, okay? And you could continue to fill out the table in this manner, just finding the sum of the values to the left and up, okay? And to write this in a better way, rather than just saying right and up, and to use actual numbers, we could say that grid, every grid at I and j, besides of course the first row and the first column, should equal grid at I j minus 1, which represents the point to the left, plus grid at I minus 1 j, which represents the point up. Okay? So let's just finish this table. This value would be 6. 6 plus 4, 10. Here, 10. And then 20. Okay, and we know that this is true because here at the coordinate point 2, 2, it's 6. And in the example, the answer is 6 for a 2x2 grid. There are exactly 6 routes to the bottom right corner. Okay, so let's just implement this and see if we got the right answer. So to start, I want to create a grid, a 20x20 grid. It'll actually be 20x21 because we need to access the point 2020, and it'll be 0 indexed. So we'll start with grid, and it'll just be an empty list for now. And then for I in range 21, because we want there to be we want to be able to access grid at 20, and for that to be the case, we have to use for I in range 21 to include 20. Okay, and then for I in range 21, grid dot append 0 times 20. Yeah. Okay, but that's not quite true, because if I equals 0, we want this to be 1 times 20, because we want the first row to be all 1s, okay? And then else, we'll just do it with 0. But we want the first column to be 0, so anytime we append a row with all 0s, we'll change at that last row the first value to be 1. Okay, so let's just see if this is working. So I'm going to say for row in grid print row, just trying to check if I populated this grid correctly. Okay, so it looks good. Yeah, we got the first row is all 1s, and then the first column is all 1s. Perfect. Okay, and now we just need to iterate through this grid, excluding the first row and the first column. So we'll start, our loop variables will start at the number 1 rather than the number 0. So for I in range 1 to 21, for j in range 1 to 21, it's this line that we wrote already here in our comment. So grid at I and j equals the one to the left plus the element to the left and to the up. All right, and then once this is done, our entire grid will be populated, and then our answer will be grid at the last entry, so the bottom right entry, because that represents the number of possible routes it takes to get to the bottom right corner. All right, so grid at negative 1, or grid at 2020, it's the same thing. Got a list index out of range. All right. Why is that? Maybe let's just increase this, maybe. Oh. Whoops. Yeah, so I was using 20 here, but I gotta just use the value 21, so it includes 20. Okay, so we get this long number. I think that should be correct. Hurrah, we got it right. I'll see you in the next video.